Hi, welcome to Electrokinematics. This is the fifth video of New Electromagnetism version 5, and New Electromagnetism is the fourth paper of ethereal mechanics, video code EM0405. In this video, we're going to talk about electrokinematics. Electrokinematics describes how kinetic energy is transferred between electronic systems. And in there, we're going to develop a new term to replace EMF, called the Vim, or the vimacity. So, the electromotive force is one of the most bastardized terms in physics. And for ethereal mechanics to go forward, we need to replace it with something sane, something that makes sense, and something that isn't so poorly bastardized in the common knowledge, because I don't want to cause confusion. But at the same time, I don't want to keep willy-nilly developing new units to confuse people. So this is very hard for me to finally come to the realization that we finally need to retire the concept of EMF and put something in its place that's much more useful to us and to reduce the confusion that's out there. So EMF has the units of volts, joules per coulomb, and therefore it's really a misnomer to call it a force. And we can't just call it a voltage because voltage is conservative where EMF is not. We are going to resurrect something that Maxwell had done. Yes, I think Maxwell was for the most part a fraud. But hey, when the guy gets something right, I give the guy the credit for it. And so one of the things Maxwell did that I like is that he claimed that a magnetic field stores kinetic energy, and an electric field stores potential energy. In ethereal mechanics, they are transfers of energy between charges. Same with the electric field. So there is no storage. What there is transfer. Okay, but that's okay. It's a semantic. We're not going to worry about that right now. But this distinction between one field being associated with kinetic energy and the other one being associated with potential energy, this distinction was discarded by Heaviside when he took Maxwell's equations and rewrote them in the vector forms that we know today. However, some of the lingo has survived. In some classes and textbooks, they'll still use the term, what's the potential difference across the resistor, when they talk about, doing circuit analysis and things like that. And that, when I was going to college, that was a little confusing. Why don't you say, what's the voltage drop? But anyway. So in electrokinematics, we're going to talk about transfer of kinetic energy between parts of a system due to a field interaction. It has to be due to a field interaction because the charges in a system do not actually touch. All right, so what we're going to do is we're going to go back onto Wikipedia and see if there's anything in the definitions or in the literature about EMF that can be salvaged. Prepare for profanities, because every time I look at the classical stuff, I start howling at the moon. Okay, so this is the Wikipedia page for EMF. And it's interesting because, there's a lot of, this may be viewed as, can be defined around, equivalent can be measured as, and okay, they're trying to give analogies because it is such a confusing system. More importantly, we are not the first ones to say that electromotive force itself is not a physical force, and these organizations have deprecated the term in favor of source voltage or source tension. Can't use voltage because it's not conservative. What the hell does that have to do with a source? Okay, they're thinking more in terms of circuits, I guess. Okay, or source tension. Not crazy about the word tension because it implies strings and is tension really like something like the term of energy per something, or I don't know. I should look at that, but we're not going to be using that. Okay, now, but the important thing here is I'm like looking at this. In electromagnetic induction, EMF can be defined around a closed loop. Why does it have to be around a closed loop? So in other words, only a closed loop can have an EMF. That's bullshit. As electromagnetic work that would be done by an elementary charge electron as if it travels once around the loop. Well, why does it have to go all the way around the loop? Why can't it go partially around the loop? The more important thing is if I can see some, physicists reading this, oh, wow, I can make myself a particle accelerator. if I just get some track, not a conductor, just like a tube where the electron can't tunnel out of, and I collapse a magnetic field around this, I can accelerate this charge around the loop and it'll pop out with a high velocity, create my own particle accelerator. Well, okay, but this isn't a conductive loop. It's just an artifact. So the question you'd have is, well, if the loop weren't there, in other words, if you collapse a magnetic field around the charge, will it follow the loop? How do you know? It's not a conductive loop of wire like everybody else uses. I mean, what if the loop weren't there? Then what would you say is going to be the direction that this charge is going to move if you collapse a magnetic field on it? Classical theory does not answer that for us. It should not have to be anything to do with a loop. We should be able to do the charge per charge interactions without any other artifact there. In other words, if electromagnetic theory is based upon the motion of charges creating disturbances in the medium, and charges react to the disturbance in the medium, then all electromagnetic interactions must be reducible to charge actions. And that's what we've done with new electromagnetism. Classical theory cannot tell you what happens here because they have not reduced everything to charge interactions. And this is one of the places where electromagnetic theory falls down and does not give you an answer. And that's going to be important later when we continue reading this page. However, if we take new electromagnetism, we can actually take our track and put lots of coils of wires around it on the inside and the outside. And then when we charge these coils up with current in the same direction, and then we put our charge in there, and then we open the circuit and let the current in the wires crash, then you'll see an acceleration of this charge in this direction. Now, granted, the charge in the wire, the current in the wire is going to crash real fast, so you're only going to get an acceleration for a very short period here. There's probably other ways to, get stage this to get collapses all the way down to keep it going, but that's another story for another day. But at least new electromagnetism gives you an answer of how this would work, in fact. As a matter of fact, I wouldn't even just limit it to the both sides. I'd actually wrap the wire all the way around, so there'd be coils of wire completely around. Now, of course, you have to redirect the wire here to go around the muzzle, so you can give it area for the charge to move out. Now, this charge here obviously is not going to be this big. It's going to be a little tiny thing, and you want to put it in the center. So now the question is, using classical theory, okay, with just the two wires shown here, well, okay, the magnetic field from this wire, let's say we're using negative current flow, it's going to have the flux at this point of the wire going in one direction, and the magnetic field contribution from this wire at the same point is going in the opposite direction. And because they have the same current, there's going to be no net magnetic field in the center. So according to classical theory, if this charge is deposited right in the center, you would get no effect from here, and that is incorrect. Absolutely incorrect. Okay, again, another thing that classical theory tells you that is wrong, because they'd be saying there's no magnetic field here, when in fact there is a substantial effect there if you let these two current loops collapse. Okay, but we keep going on here. So now this isn't really giving us any information about electromagnetic theory. So now let's go look at the page for electromagnetic induction. So if we click on this, it brings us to Wiki's law of Faraday's law of induction. We got to stop calling these things laws. They are not laws. This gives a false impression that we actually know what we're doing and that we have fundamental knowledge of physical laws. We don't. These models are empirical, and they match our observations of nature. That's all they are. They're nothing more than that. Okay, science is nothing more than monkey see, monkey do. And just because monkey do does not mean monkey know. Those are in the rules of acquisition. Okay, but here anyway, this is a nice causal relationship. The change in magnetic field around the loop gives you an EMF in the loop. This term symbol here means EMF. Now let's go on, because Maxwell turned this into what's known as the Maxwell-Faraday equation. Okay, and this, what I've been screaming about for years, is that this can't be true. Because if you look at Kirchhoff's voltage law, it says the curl of an electric field is 0. So it can't be 0 and also equal to minus dB, at the same time. Okay, but they've been listening to me because you'll notice here they're using the term non-conservative electric field, which is jargon. An electric field is conservative. You can't have a conservative field that's non-conservative. We need to call this something else. Okay? And worse off is when they're defining E over here, okay, they define it as the electric field. So after they just got through telling you it's a non-conservative electric field, they give you the link to the conservative electric field page. Talk about, I mean, this is the part where I'm just like, Jesus, I feel like these are monkeys playing with matches. That's how ridiculous this has become. But it gets better, folks. It gets absolutely better. Because look over here. See, I showed you this was causal. Now, read this. The Maxwell-Faraday equation states that a time-varying magnetic field, which is this, always accompanies a spatially varying, also possibly time-varying non-conservative electric field, and vice versa. Oh my God. Talk about monkeys playing with matches. First of all, let me break this down. Time-varying magnetic field, no problem. Always accompanies a spatially varying. I am sorry, this is bullshit because this is a point equation and defines no spatial variation of this. This is bullshit. And also possibly time varying. I'm sorry. I am very sorry. This is static if this is time varying. There is no indication of time varying in this equation. If this is constantly changing, this is supposed to be static according to the equation. And here's the worst part. It says always accompanies. This means these happen simultaneously. This is what I talk about with the abuse of mathematics. Okay, because this is basically saying, oh, well, yeah, this is an equivalent. It's happening at the same time. Really? No, sorry. That would be an over-unity condition. That would be an ambiguous condition. We've gone from a causal relationship to a simultaneous relationship. This is complete BS. And then look, they go, so not only is it accompanies, and it's a vice versa. Well, that's ambiguous. So we got a simultaneous equation that's vice versa. Okay, and I'm like, who wrote this crap? This is complete fairy tale nonsense. I mean, this is woke physics. It's like whatever you want it to be, it is. All right, so this is why I get my blood pressure up, and I do not like looking at classical theory, because the people that are supposedly in charge of classical theory are completely out to lunch, and they don't have a freaking clue what they're doing. Okay, but it gets better. The for Maxwell's equation, which includes the Maxwell-Faraday equation, along with the Lorentz force law, are sufficient foundation to derive everything in classical electromagnetism. Well, I just showed you at the beginning of this video some instances where it does not give you the answer. It does not give you the correct answer. And therefore, it's possible to prove Faraday's law, starting with these equations. Okay. So, I'm not going to go through this proof with you. I'm just going to tell you what it is. What they do is they use Faraday's law to derive the Lorentz force law, which is F equals QV cross B. And they think that that proves the irrefutability of electromagnetism as they have defined it. Well, let me give you an example here. Let's say that you were to use Newton's law of gravity and we were able to derive Kepler's laws from them, which is doable. People have done this. Does this prove that Newton's law of gravity is the irrefutable expression for gravity? No, it is not, because we know it's not complete representation of gravity. That's why we've gone on to other things like special relativity, and I've gone on to the cosmology of ethereal mechanics, because Newton's law is not a complete representation of gravity. So just because two mathematical equations agree with each other proves nothing. All you've proven is that they are consistent with each other. It does not prove that they are consistent with the natural laws of the universe. And because this goes on to the math fallacy, which is the rule of acquisition 12, which states that derivations are not proof. Nature cannot be proven mathematically. And here's where these new graduates are going to be screaming and yelling at me as oh, you should go out and learn math. No, I've learned enough math to know that math is flawed, number one. It's not complete. They have a lot of undefined things that they really should be defining. And worst of all, people abuse math. I've seen, and I have a video of this person who I believe they are considering themselves a physicist, or I believe they are a professor, who derives, using these models, derives that magnetism and electricity are the same thing. And her derivation is flawed, doing wrong things, converging variables that should not be converged to get the answer she wants. And that's what people do. They don't know how to use the math properly. And math is a superset of nature. Math can define a universe with infinite dimensions, even fractional dimensions. But our universe, according to the physicists, is only about 12 dimensions. So therefore, if you derive something in math, you could possibly derive something that does not exist in our universe, even if you follow all the rules. So just because you derive something with math does not prove that it's true in our universe. Okay? And the other problem with their derivation here, again, is that they require that the magnetic field move with the coil, and that's a violation of locality, rule of acquisition 25. Okay? All right, I got to calm down now. Let's go back to what the whole purpose of this video is, and calm down, get my blood pressure down. What we're going to do is we're going to use the Faraday's loop experiment to show you what EMF is in relation to the voltage that we measure. So here we have a loop of wire. Let's say it is a resistless wire. It's a lossless wire. It's like a superconductor, let's say. Then what I'm going to do is I'm going to cause it a changing magnetic field to couple with it. Now I'm just showing one little X here. This is not meant to show the complete field. I don't want to have to go and make this complicated diagram. Just little X just represents that a magnetic field has now coupled this wire. That's it. That's all we're saying. So the minute that we get that change in the magnetic field, that is going to couple and what we used to call an EMF to the wire. This is a kinetic energy transfer. Okay, but this EMF is not going to last with the magnetic field. It's going to dissipate very quickly. But that doesn't matter because the energy has been transferred to the charges in the wire, and the charges are going to flow around and around forever and ever and ever and ever and ever. And you can put a voltmeter between any 2 points in this wire and you'll measure 0 volts. Doesn't matter where you put the two probes, you'll measure 0 volts. So let's say a month goes by and you really want to trying to figure out how to determine if there really is charges flowing in the loop. So you decide, oh, I figured out a way. I'm just going to cut the loop and I'm going to insert a voltmeter. And that voltmeter gets an instantaneous reading. And it's a real reading. It's a reading of potential energy, of real volts. And strangely, this reading of real volts is in the same direction of what would have been the EMF that was applied to the wire a month ago. You're like, well, how can that be? Well, in the next pages, I'm going to show you step by step what's going on here so you can understand there's a two-step process going on. That's why our equations are a little bit of a misnomer because it is a two-step process. And that's why we need to dissociate the EMF from voltage and all that other stuff because the voltage is the second step of what you measure. Let me show you what's going on. So what we're going to do is we're going to use the loop condition, the Faraday's loop, but we're going to keep the voltmeter installed in the gap at all times. And right now, this is this initial condition. Everything's steady state. The blue charges represent mobile carriers. The pink charges represent the other charges in the loop, the stationary or the uncovered or unbalanced charges, whatever you want to call them. Okay, and right now the voltmeter reads 0. Now we're going to implement our our field change, and that's going to impart kinetic energy into the mobile carriers. It's also going to impart kinetic energy into the non-mobile carriers in the opposite direction. But the problem is, because these carriers are bonded into the wire, and the wire has a lot of mass, the wire is pretty much not going to move. But it should move just a tiny little bit. Okay? Because for every action, there should be an equal and opposite reaction. Otherwise, we're not doing real physics here, are we? Okay, then in the next instance of time, okay, these charges are going to start to move. Okay, these arrows should have diminished. I'm sorry, I should take them away. And then after a little bit more time, they're going to start giving up their energy. And what's going to happen is, on this side of the loop, the mobile carriers are going to deplete, leaving just the non-mobile carriers producing a field. And on this side of the gap, the mobile carriers are going to bunch up, and they're going to produce their version of their field. So this shows the diagram that the electric field is going to, it's like a gap in a capacitor. So the field is going to be from, we're saying now the field goes from the mobile carriers to the non-mobile carriers. So the electric field is going to go this direction across the gap. It's going to go this direction across the voltmeter, which is the same direction as the original applied EMF. It's also, like you can see, these guys, they leave unit, and it's going to go around. So we just see the electric flux line going the opposite way around the loop. It's this electric flux that goes the opposite way around the loop that opposes the energy imparted into the mobile carriers and shuts them down and starts reversing their direction to go in the opposite direction. Okay, and this basically will then cause, because there's no loss, the current is going to slosh back and forth, around and around, like a tank circuit, or like the water sloshing around in a bucket. And this meter is going to show alternately positive, alternately negative, alternately positive, alternately negative, based on the size of the loop and the amount of capacitance in the gap. Okay, now an example for this that we see in other parts of physics would be what we call the pendulum. So suppose you had a bullet over here fired from the left at the pendulum, and the bullet strikes the pendulum. Then what's going to happen is going to impart kinetic energy to the pendulum. And then what's going to happen is the pendulum is going to rise. Okay, there's our kinetic energy, and it's going to rise up. And then eventually gravity is going to apply the opposing force, which is going to cancel the motion upward when the potential energy is equal to the kinetic energy that was applied at the bottom. Okay, this is another common known physics problem, and this is the same thing happening in the loop of wire. The changing magnetic field imparts kinetic energy. The kinetic energy and the charges are dissipated across the gap, and then eventually the wire, the charged wire will slosh back and forth. Just like the pendulum, once it's retarded up here by gravity, it'll swing back down, and the pendulum will keep on swinging, assuming there's no losses in the pendulum. And just like the tank circuit, the charge will slosh back and forth. It's the same physics. Okay, but of course there's loss, so the pendulum is going to slowly, wiggle down to nothing. Okay, but again, what I see a lot of people do is they abuse mathematics. Okay, but this is a tolerable violation, because a lot of times, in order to find the height that the pendulum will go, they'll set the potential energy equal to the kinetic energy, and then they'll solve for the height. Okay, but there's a problem here in mathematics, because these are not equal at the same point in time or the same point in space. And we have no mathematical representation to say that they're equal in magnitude only here. All right, I mean, you have to know it out of context if that's what this means. So this is a tolerable violation, but unfortunately, especially in electromagnetism, when they come up and say to me that both sides of the Maxwell-Faraday equation occur simultaneously, vice versa, that's weird. That people will solve the causality both ways on that equation, then they get into so much trouble. Okay, the Maxwell-Faraday equation should have the same causality as the Faraday equation. Okay, but this is, again, the stuff that makes me howl at the moon when I look at people trying to use classical theory. Like I said, it's like watching monkeys play with matches. Okay, so what we have to do is we have to replace EMF. Now what you see here are the three models of new electromagnetism V5. This is the new Coulomb model. This is the new magnetic force model. This is also called the electric force model, magnetic force model, and inertial force model. So what they typically do in the electrical field is they'll take and divide out the QT on both sides, and they call this force per coulomb, they call that the electric field, which is a little bit of a misnomer because it's not really the field. The field is, well, that's another semantic for another day. This is just what is done, and this is useful. We need the same thing for these. We cannot divide by Q and say these are also E fields. So we're going to divide by them and say this is the M field and this is the I field. For electric derived E field, magnetic derived E field, and inertia or inductive derived E field. The voltage, this is the voltage. So if we take a path integral through this field, we're going to end up with voltage. In the old days, when you took a path integral through here, you should have ended up with EMF, but then that leads to the confusion. So what we're going to do, we're going to use a term meaning voltage, but either from the I field or the M field. Voltage from the I field or the M field. But we're not going to call this voltage. We'll get to that in a moment. This is going to be called something else because we don't want to use the term voltage. We're going to come up with a new word called Vim, just like you see here. So this is voltage and this is Vim. Vim is actually a word that means energy. Okay, now in order to distinguish legacy stuff, we can put the VE there just in case we're intermixing these to keep them straight of which one's conservative and which one's non-conservative. The definition of conservative is that if I take a path integral around a closed loop, that's what this means. I should get 0 in an electric field. However, for a Vim field, that you will just get the Vim value because it is not conservative. Strangely, Vim actually has a meaning, which means energy enthusiasm. So that's going to be the unit that we're going to replace EMF with, so we don't confuse it with voltage. So the usage is for normal volt, you're going to use the capital V or the VE, and use the term voltage or volts or potential difference or potential, depending on where you went to college. The unit of the voltage is volt, which is potential energy per coulomb. And because voltage has the word volt in it, we can do the same thing and say, I tried coming up with, this represents verve or viscosity, vig or whatever. We're just going to say vimacity. Just like them, we're going to put the unit in the word. This is a made-up word. It's purple. And so Vim is the kinetic energy per coulomb. And that's the term Vim. So we got Vim, vivacity, volt, voltage, volts, whatever. You can read this on your own. This was replaced by the previous few pages. So in the next videos, which are going to be for Patreon members only, they will be released to the public at the 1st of 2024. We're going to apply the fragment-to-point model to compute the interfragmentary vivacity. I keep saying vivacity, vimacity. And then we'll show you the experimental and simulation results compared. Okay, then we're going to start delving into the new magnetism V5 model of magnets and then go into dynamic charge motion, Coriolis charge motion, centripetal charge motion, and Venturi charge motion. I want to thank my Patreon members for sticking with me through the thick and the thin. And one of the things I'd like to do for you now is I want to add a dedication page to the beginning of New Electromagnetism V5 paper as it's submitted to the Copyright Office for formal copyright. We'll do other things later, but right now this is at least the things I can do. But if you do not want your name included on that list and you're watching this from the Patreon site, please leave a comment saying you do not want to be included in that dedication page. For those of you who are not Patreon members, because this video is being released early, this is one of the few New Electromagnetism V5 videos that are being released early as a teaser to let people know that New Electromagnetism V5 is being produced and will be out to Patreon members. They're getting the chapters now. They're seeing the videos of each of the chapters of the paper now. You, the rest of you, will not see them until January of 2024. Okay, but don't sign up to become a Patreon member if you're just one of those people that want to be entertained. Right now, we are in the quest stage of this quest, this venture. And as in any quest, there's going to be times where things are going slow and times like now where things are going fast because connections are being made very fast. And my Patreon members were patient for me because one couple of years we had to take a divergence into developing a new math. And then there was another divergence into how gyroscopes work and how does precession work, and found out, it's only Coriolis force. But then later on, it made the connection that Coriolis force is actually what we need to compensate new electromagnetism V5. That was a happy accident, okay, which was very exciting if you were there and watched it. So maybe later, once we get the physics battened down and we can start making the fantastic machines, who knows, maybe we can get Mark Rober to make some of the machines, or even Derek from Veritasium if things go well. Then we'll be more of in an entertainment phase as we start making the fantastic machines from the theory. But right now we're still in the quest for getting the truth nailed down. So to my Patreon members, I thank you very much. No more voodoo physics.